All right, so here's a quick review for you on properties of logs, which are going to be very, very, very useful in the calculus involving logs. Um, we use these to expand and condense log expressions. In calculus, at least for derivatives and integrals, um, we're usually expanding. Well, especially for derivatives, we're going to be expanding. Condensing is not going to help us in derivatives because it's going to make the problem harder. You're going to have to, it's going to bring in quotient and product rules that you don't want. But expanding is going to do just the opposite. It's going to allow us to avoid product and quotient and chain rules. So in this video, I'm just going to go over expanding. Condensing is very important if you're solving these log equations. You should review your trig stuff for that. So anyhow, expanding a log. There's three properties that we're going to use. The first property is if you have the log of a product. I'm always going to use natural log here because that's what we're going to see mostly. But if you have a log of a product, like A times B, that expands into the log of A plus the log of B. Um, if you have a quotient, A divided by B, that would be the log of A minus the log of B. And finally, if you have the natural log of something that is raised to a power, so we'll say a to the n, you can basically bring that power down. It's the power times the natural log of the base. So that's how you expand logs, and that's going to be very, very useful to when we take the derivative. And there's like major shortcuts on this. For example, if I had the natural log of say x plus 2 times the square root of x minus 9 all over the, let's go, x plus 7 to the 8/9. Okay, so you can apply a lot of these properties to this. You can make this, basically it's a quotient. You can make it the log of the top minus log of the bottom. And then you have the log for the sum of the top, and then you can bring down all the exponents. So I went through that really quickly because it's, when you practice this, it's really easy to shortcut the whole thing. Basically, when you expand this, everything up top is going to be positive. So we have the natural log of x plus 2 plus, next is the natural log of the root of x minus 9, but the exponent on that x minus 9 is 1/2. So it's just plus 1/2. Bring it down right away. Natural log of x minus 9. And then the bottom is a minus. And then the 8/9 is the exponent that comes down. Natural log of x plus 7. And that's it. So one thing I like to say, though, is remember that whatever's on the bottom, it's always going to be negative because that negative would be distributed in the first place. So, for example, if you had the natural log of, say, the fifth root of x plus 10 over the square root of x times x minus 7 to the fifth. This would expand to be, the top part is going to be positive, so positive 1/5, that's the exponent on the fifth root of the natural log of x plus 10, then minus 1/2 natural log of x, that's on the bottom, and then again minus, taking care of the x minus 7 term because that's on the bottom. The exponent is 5 times the natural log of x minus 7. It is really easy. Just don't do what you're not allowed to do. If there was a plus between this, you couldn't do that. This only works for quotients, products, and exponents. And that's it. you have to get really good at doing this because it's going to make the derivatives of logs much easier to do. So practice that if you need to.